The next topic is union, insert, intersect, and accept. One more thing is that all of them work on result sets. So what union does, union actually combines the output of two queries, meaning the results of two queries are combined. So something like this, let's say we have a select statement, this is the first query, then you have another select statement, which is the second query, and if you put union, the output would be the result set of this query and this query. So there are some caveats that the output columns and its data types should be same for both the queries. If they are not same, you can use the cast function to change the data type of the columns. While combining the result set, union also removes the duplicates, meaning that if there are any duplicates, it would remove. But if you do not want to remove duplicates, we can use union all. So it is similar to union, but it does not remove duplicates. Likewise, we have intersect, and what it does is it only outputs the common rows from the two result sets after removing duplicates. So it is similar to join, but not of the tables, but of the result sets. So let's say you have query 1 and then query 2, and we mentioned intersect. Only the common output would be returned, right? So that's what intersect is. And then accept would return all the rows that are in first result set but not in second result set. So let's say we run this query select query 1 except select query 2. What it would do, it would return all the rows of the output of this query which are not there in this query. Only those would be returned. The common rows will not be returned. So let's do some hands-on. What will I do is that I'll use the customers table because the number of records are less, so it will be helpful. So I'll use only one table here, but of course you can run these queries on multiple tables. And these are the rows that I have, approximately 10 rows. Now let me select customer ID. So first of all, let me show you the output of this. So what I'm doing here, I am using customer ID, address and date of birth from customers, and I'm putting an union. This is the first query and this is the second query. Select customer ID, address, but instead of date of birth, I'm putting phone. So union should give me error. It says union types, date and text cannot be matched. So we have to put a column which has the same data type. Now, if I put country, so it says that data types date and text cannot match. What is happening? The date of birth is data type date and the country data type is text. Now what will I do? Let me change the date of birth to phone. Now it should output because the phone data type is text and the country data type is also text. So that's why I'm seeing the output in both the cases. Now there is only one row. If you see, the duplicates have been removed. So this is the rule of matching data types. So even though the columns are different, as long as the data types match, you can run union statement. Now let me run one more union statement wherein I will remove one column altogether and it should give me error. So it says that the union query must have the same number of columns. So this is the caveat that the number of columns should be same for union and the data type of those columns should also be same. Now let me select date of birth from here and date of birth from here also, and I should be able to see only the rows that I have, so which are 10 rows. The customers table by itself has 10 rows. So it has removed duplicate and has shown me the output. But if I put union all, the duplicates will not be removed. Now I am seeing 20 rows and 1004 is there two times. So the same data is there two times because again, of course, it would be same data because I'm joining the same table. If I want, I can combine result set from different tables also. For example, I have customer ID, address and date of birth, and let me union with customer ID, payment method and order date from orders table. So Now what am I doing here? I am combining the output of two result sets. So this is the first query, and it is returning result from customers table, and this is the second query which is returning results from orders table. But as the data type and the number of columns are same, it should give me the output. So as you can see, these are the output. So in address I am seeing visa, in date of birth it is fine, I am seeing order date also. Now why I am seeing customer ID, address and date of birth? Because that is the first table. So the column output would always be from the first table. So this is not a use case. This is not how you use union statement. Typically what you do is that, let's say you have two different tables and you want to combine the result from two different tables. That's when you'll use union. And let me look at the customers table one more time. And what will I do? Let me select two different result set. Okay, so let's do a select star. And what will I do? In the first result set, I will select the country to be Nepal, and in the second result set I'll select the country to be India. So let me do a select star from customers. So it should obviously show me only two rows. Same is the case with India, it will only show me two rows, but I can union these two. So in this case, as you can see, it is showing two rows and it is also showing two rows. So now this query can be combined with this query. So the finally we get the combined output, and I can see only India and Nepal. So that's what it is. That's what union does. And I have used a single table, but as I said, this is not how you'd use union. If you are using union, most of the times you will run select statement, you will return results from two different tables, but the results would be similar. That's when you'll use union. The next one is intersect. So what intersect would do, it would return the result from two different queries and combine only the rows which are matching and set the output. So what will I do? Let's say this is the first query, but instead of Nepal, I'll give one more country. Let's say Hungary. And it should return three rows. In the second one, I'll mention the country is India and Hungary. So I have, for the first select statement, I have output wherein the countries are Nepal, Hungary, and Nepal. For the second one, the countries are Hungary, India, and India. Now, if I intersect these two, so let's say this is the first query, I can put a bracket also and then let's say mention intersect and then run the second query. So now if I execute, now before executing this, you can pause the video and try to find out the result by yourself. What should be the result? I hope you are done. The answer would be only one row, that is Hungary, because that is common in both the result sets. So the Hungary is common here also and here also. Basically, this is the same row. Now, if I run except here, what would happen is, so the output would be only the first two rows because the common row of the second result set would be removed. This tells us that these two rows are not there in the output result set of this query, right? So that's what except is. And if you put this query at the beginning, let's say, now it should show me India. So these are the two outputs, which means that these two results or these two rows are not there in the second result set. And the use cases are very broad. You can use these queries to find out data relevant to your business. So let's say you have a retail store and you want to find out products which have been sold here but not here. You can use except. You want to find out products which have sold in both in, let's say, India and let's say Nepal. You can use intersect. You want to find out orders or products which were sold in India but not in US. You can use except. So the use cases are very, very broad of these statements. And the next one in the complex SQL topic is views. So what are views? We have seen that whenever we run a complex SQL statement. So we have, let's say, joins across multiple tables. We run the query and we get the output. So this is a complex SQL statement. What happens is, let's say you do not want to give the complex SQL statement to everyone. So what you do is you create a view based on that SQL statement, and then you give the view to someone else, give the name of the view to someone else, and that someone can run a select star on that particular view. So we create the view like this, create view followed by view name as then the select statement. Once the view is created, we run select star from the view name. So what would happen is, whenever we run select star from view name, it will go ahead and execute the select statement. The results of the select statement will not be stored in the view. So even if you run select star from view, it will actually go ahead and execute this particular select statement based on which the view has been defined. Remember that, that is very important. The major use case of creating view is security reasons. So let's say you do not want to allow direct access to tables and all of its data. So let me tell you, so let's say this is the select statement. So I've mentioned select star from orders where payment method equal to Visa. That is the first SQL statement. And you create a view on top of it. And you name it as, let's say, Visa view. And what you do is you grant access to this view to a certain users. So they can see records from orders table where the payment method is only Visa, not something else. Then you create another view where select star from orders where payment method equal to MX and create a view on top of it. Let's say you name it as MX view and you give a separate user permission to access this view. So what would happen whenever that user runs select star on this view? This SQL statement would run select star from orders where payment method equal to MX. So this user would be able to see only records which pertain to MX. Using these views, you can basically secure your data across on a single table or multiple tables also. Now here I am just showing you a very simple table, but typically views are created on complex SQL statements. So what will I do is that I will create view on a very complex SQL statement. So I'll use the customers table, I'll use the sellers table, and I will use the orders table, of course. Now these are the tables. I'll join these three tables and create a view based on the payment method. So this is the SQL statement: select order ID, order date, payment method, and discount from order table, date of birth and email from customers table, and seller company name from sellers table. And I'm selecting orders, aliasing it as O, customers as C, sellers as S, where O dot customer ID equal to C dot customer ID and O dot seller ID equal to S dot seller ID. This is also a form of inner join. Remember that. Even though I have not mentioned inner join here, if you use comma and if you use something like this, it also becomes an inner join. So now why have I used customer ID from order table and customer ID from customer table? Because that is the common column between order table and customer table. Similarly, seller ID is the common column between sellers table and orders table. So that's why, even though there is no primary key or foreign key or any referential integrity are there, I'm using this particular these columns, right? And after that, I'm using payment method to filter out the values also. Now if I execute this, this is the output. Now of course we can run it multiple times, but what we do is, instead of running it multiple times, let me create a view. So it is very simple. Create view, let's say mx underscore view, and then as, just copy and paste the select statement. That's it. We are done with creating one view. So this is the command, and if I execute, the view has been created. Now if I do a select star from mx view, the output would be exactly same as that of the select statement. So what is happening? as I'm running select star from the view, the database is going ahead and executing the select statement as is. So it is not storing any data in this view. It is just storing the definition of the statement, meaning the statement itself. So the view is storing, this MX view is storing this particular statement. And whenever I run select star from MX view, it is basically referring to this select statement, and the statement is getting executed. Right. Similarly, I can create another view as visa view. Now the payment method, instead of American Express, I can mention equal to also. So equal to a visa. So it has been created. If I do a select star from visa view, now what is happening? This particular SQL statement will get executed and it will show me the output, but the output is only visa. Now what can I do? What can I do? I can give access to this view, to MX view, to the MX operator, and visa view to the visa operator, and I give the view definition to those operators. Now the visa operator, or the MX operator rather, would never know what table is there underneath. Same is the case with visa operator. He or she will never know what is the table underneath and what columns are there. So by creating this view, I am saying that the operator is only allowed to see order ID, order name, payment method, discount, date of birth, email, seller, company name, not even customer name, customer address, country, anything else. This is how view helps. Basically, it is used for as a security mechanism. So you can create views to store the definition of multiple SQL statements, and then you run select star from that view. And the moment you run select star, the SQL statement will get executed and then return the result set. So that's all about view. And I hope you have understood the use case of the view. It is one of the major use cases, security, so that no one can see the underlying data in the table, and you give access only to the view, not to the main table. Another use case is to store very complex SQL statements, or the definition of complex SQL statements, in a view.